Hello and welcome to what is, if you hadn't guessed, a Halloween edition of Crawl Error. Today I'm joined by Dave Smart from Tame the Bots, who is going to be chilling our souls today about core web vitals. Hello Dave, how are you?
I'm well, thank you, Dan. Thank you for inviting me, and I hope we can have some fun.
Yeah, no, I'm happy to have you here, and also the effort that you've gone to in terms of getting into the spirit of things and making my drop run look a little bit to shame. Thank you. So over to you, Dave. Thank you.
Okay, right, I shall share my screen. Hi, I'm Dave, as Dan just mentioned, and I'm here today to talk to you about Core Web Vitals. I'm a technical SEO consultant and a developer, also a Google product expert, and I'm here to tell you don't need to be afraid of them. So let's moving on. And basically, so what are Core Web Vitals? Well, they're three performance metrics, simple ones, simple in quotes. Google initiative to make sure that quality scores are unified across many different places. And you can get them in lots of different places. We all know we talked about them. In the past, there were so many, there was loads of different metrics. It got a little confusing and a little hard to judge and understand what we're supposed to be looking at. So there are three new metrics. There's largest contentful page, which is mostly about speed. There's first input delay, which is about interactivity. And there's cumulative layout shift, and that's about the stability. So let's have a look at what these are. And let's start with largest contentful paint. LCP is the time it tends to take for the main content, which is pretty much the largest element in the screen, to appear on this So it's only the stuff that's in the viewport, which is the bit you see, quite often called above the fold, that's counted. And most, but not all elements are eligible, but things like text, images, video, but for the post-roaming stuff are. These things are subject to change as time goes on, but that's what it's looking at now. So this is a bit of a diagram to show how the LCP is judged. As a page loads, different elements will load in on your site, and different elements might become the largest contentful element. If you have a look here on the CNN site, it starts with a little bit in the corner, then it's the headline, and finally it's the image, it's the header image that becomes the LCP. These are all measured right until the point and when you touch or scroll or interact with that page. At that point, it's the LCP measurement pretty much stops, and that's your LCP. So the largest element that's in the screen at the time of interaction is your LCP. And what it is, it's the render time, which basically doesn't mean how much time it is until it loads in. It's until it's actually painted on the screen, and measured in seconds. There's three levels. Anything under 2.5 seconds, that's good. Between 2.5 and 4 seconds, you could probably do some work on that. Over 4 seconds, they're judging that as poor. One little note here, a little foible: if you're calling in an image or something from a CDN, something that's on a third-party domain, unless you set some headers, then that render time might not be available. So it kind of falls back to the load time, the time that something's just loaded in, which is a little bit rougher. It's not as accurate, but it's normally not that different. So it's not a huge difference. And you might wonder, well, why have they picked this metric? Well, it's a good proxy to the speed of the important part of your page, the thing that's going to catch the eye, the thing that your reader, your user is going to be interested in. And pure speed metrics, like you might have heard of time to first byte and stuff, don't really tell the whole story. That's just about how quickly they fire stuff across the net. It's not how quickly it's ready to use. And some of the other ones that involved with painting and stuff in the past, you might have heard of first contentful paint or first meaningful paint, can be a little bit misleading or inconsistent. First contentful paint, who cares if it's a bit of a breadcrumb? And first meaningful paint, a browser can often not really decide what meaningful is. So that's why they've gone for largest, which in most cases is the most important part on your page. So your next one is first input delay, and that's all about interactivity. So it's about how long your site takes to listen to and respond to a user input. It's basically a function is, are you keeping somebody's browser too busy with all your stuff to let it listen to your user and it clicks? So it can be clicking a link, tapping a button that causes a function to run. It can be some sliding function. It can be some JavaScript UX thing. And basically, it's important to keep these things running, flowing smooth. So what it isn't, it's not a measure of how long the things take to run. So if you click something, it goes off and fetches something. It's not a measure of how long that fetches. It's a measure of how long it is until it starts doing it. So here in the slide, in an example, if you've got a little on-click button that releases the bats, then the FID would be the time until it starts to listen to it's ready to release them, not how long it takes until those bats to flutter out. Like LCP, that's also judged until your first interaction, to your first tap on the screen, to your first interaction with it. So that cuts off pretty much often the same time as the LCP does as a measuring point. So it doesn't sort of keep things, so it does not, each interaction is the first one. So the first interaction is the one it's listening. It's measured in milliseconds, and these are quite short, they're quite restrictive. So a good time is it ready to listen to you in 100 milliseconds or less from when you first started tapping. If it's taken between 100 milliseconds and 300 milliseconds, time to have a look at that. If it's over 300 milliseconds, it's going to be a bit annoying. So why this metric? Like I say, it's a good proxy, it's a good metric as to how the user perceives your site and how it's working. Something that loads visually and quickly, but doesn't work, even though it looks like it should work because all the content's there, it makes it look like it's broken. It makes it look like your site's maybe not quite right, and it leads to rage clicking. You're clicking away, nothing's happening, you hit that buy button 20 times, people disappear. People don't like that. It's not a good thing for your users. So the third metric is cumulative layout shift, which is about the stability of your site, really. It's about how much things move around on your page. And it's one of the first away from the old speed metrics that we used to get, because this one's purely about user experience, as opposed to some of the older ones that were just purely about how quickly things arrived at the user. I mean, speed can play a part in this, but it's not really the main focus of it. The metric isn't quite like with other ones, as this lives throughout the entire life cycle of the page. So as you scroll up and down, as you interact with things, as images appear, it's measured all the way through when you use the page. Very broadly put, it's a measurement of how much stuff moves between render frame and render frame. So somewhat like a video, you might be used to frame rate in the video. Your browser has one too. So it's measured between each browse frame and how much has changed between there. And as Cumulative says, it all adds up. So there's a little bit of maths involved with this, but it's not too scary. The formula to calculate the layout shift is the impact fraction by the fraction distance, or the distance fraction, should I say. And that is the union of the visible areas that have moved between the previous frame and the current one, which sounds quite confusing, but it's not that confusing really. If an element took up half the screen and then it was pushed down from the top by 20%, that would mean that when you add them both together, that would be 70% of the entire screen that you see has been affected by something shifting. So as a fraction, that's 0.7. So this is it off the Web Vitals excellent document. You can see it visually. That's taken up half the screen. This in this example, it's moved a quarter. So as the red dotted line things, there's 3/4 of the screen has actually been affected by shift there. And then the other part of that equation is the distance fraction. It's how far these elements have moved between the two frames. So in the example I gave in our calculation, it moved a fifth of the screen, that's 20%. So the fraction would be 0.2. So then the score that you get for that would be the fraction times the distance, and that becomes 0.7 in this example. So it's worth bearing as well that it's not just one element, there could be multiple elements moving, and it's all of those added up together. So you could have a div up here that moves down and a line of text down there that moves down. They're all added up together. And another point to remember is you won't see CLS assigned to something that appears. So if you add something above something else, it's not got CLS, it's what it affects has CLS. So when you shift something up, down, left, or even I suppose you could shift stuff up, then that's, although the cause of CLS, it's hard to sometimes see in the measuring tools because it doesn't get a CLS itself. And also exactly the same is true if something is removed. So if you delete something and stuff moves up or to the left, then once again you'll get shift. But some shifts are expected. When you interact with something, you might expect something to pop up, appear, or move. So there's a little delay. There's a 0.5 second delay at the minute. So when you tap something or interact with something, CLS measurement basically stops. Strictly speaking, in behind it just gets a little value to say, oh, we've had interaction, don't listen to this. But basically that's to cover expected appearances. So you clicked on a button, something, a line of text appeared. You want that to happen, that's fine, that's okay. But with that 0.5 seconds, it also says make sure it happens with 0.5 seconds. So why this metric? Well, it's really annoying. I'm sure we've all been there. We've gone to click a link, we've gone to hit the buy button or something, and oh, it shifts, like Vlad here. He's jumped out his coffin, it's not going to end well. And you could end up deleting things, you could end up adding something you don't want to your cart, subscribing stuff. So stability for that is really important, particularly for something that's more app-like, like a shopping cart thing. But even when you're reading, as you're scanning down a page, a paragraph of text jumps down out of the way, that's really not a great experience. So those are the three vitals, and those are kind of why they've gone for those. So we know what they are. How do you measure them? How do you know what they are for your site? And before you can fix something, you want to have a know what they are, and if you have fixed something, you want to know how's that improved. So there's loads of different places you can get the vital measurements, but basically you can group those tools into two things. There's lab tests and there's RUM tests, or real user measurement tests, and we'll have a look at what those two are. So starting with lab tests, they're simulated, which basically means there's a script that runs somewhere and it attempts to look at the page and analyze it and judge what it thinks a user would get. So we've got things like Lighthouse, Page Speed Insights, there's webpagetest.org, there's many others. Many of them actually are powered by Lighthouse and this part behind of it. Webpagetest.org are slightly different and they've got their own. They're very great, they're handy. And pluses are, they're immediate. You make a change, you want to test something, you get that data there and then. But the downside is the connection speeds might not be realistic. They're always stable, they're running from some microscopic powerful server somewhere, or if you've got it in Lighthouse in your own browser, your own connection on your nice big powerful laptop. So they might not match your users. They only take the initial load into consideration as well. So that means that they can't scroll up and down a page, they can't interact with it. That becomes very important for CLS, particularly if a lot of your CLS is caused by elements appearing and disappearing further down the page. And there's no FID. FID is purely a user measurement. So you can get around that by using a different metric called total blocking time in Lighthouse tools. But they have the downsides. So they're great for immediacy, but they're not the full story. So onto real user measurement. These are actually collected from people with devices that are visiting your site. You can find this already in your Search Console report. That's based on CRUX. You can find it on Page Speed Insights. If it's got field and origin data, that's from the same source, from the CRUX. You can also use the CRUX data source yourself. You can query it. You can build nice little dashboards on Data Studio and get that information from there. Or you can collect your own. So measuring in real user measurement is the greatest plus is this is what's actually happening. This is what the people who matter, your users, are seeing. The downsides are that they're reactive. They'll tell you that there has been a problem that people have seen. They're not so good at spotting something up front. They're not proactive. And because they take a while to collect, you know, there can be some lead time from that. The other big problem as well is if you're relying on CRUX to get your data, so that's in Page Speed Insights, that's in Search Console, they don't cover everything. They only cover, you know, relatively popular sites. They cover 4 million or something these days. That's quite a lot, but there's an awful lot of websites. And if you launch a new section on your site, a new URL, even though that might be popular, there's still a good 30-day lead time sometimes until you're going to start seeing that data, even if there is enough data to show. So no matter how big your site, you might need to have a look at that. So which one should you use, Lab or RUM? Well, both. You should definitely use both. RUM data, I would say, is ultimately it's the best data because, as we've covered, it's what's happening. It's not what it looks like should happen. But you should be using lab data to get that immediate feedback and say, this looks, yeah, it looks well. It looks like this should react well. So when you're developing, use lab data like Lighthouse or something to make sure you're not regressing and things are working well. And then keep an eye on the RUM data itself. So as I say, to overcome the fact that CRUX is a luxury not all sites have, and not even the biggest sites have full coverage, there are ways to collect your own. If you can integrate with Web Vitals from Google, and they've released a library on GitHub. SALT.agency have created a wonderful WordPress plugin that lets you collect these and filters it out into analytics. There's also a kind of half stage. You can use the Chrome Vitals use extension, which lets you see all the metrics as a user would. I've also done a bookmark that you can see. The big caveat with that is it's kind of real user measurement, but it's not, because that uses you. So it's not a wide range of data. It's not across different connections and different devices, but it can help you get those FID figures. It can help you get those figures that the lab tools directly can't. And as I mentioned, if you're using lab data alone, use TBT, which is total blocking time, as a proxy for FID. They marry up quite well. If your thread isn't blocked for the TBT, then it's probably not blocked for first input delay. So what do you actually do about them? You've got to measure them. Mine's not great. What do I do? Well, every site's different. There's no one method to fix all CWV or Core Web Vital issues for all sites. But there are common themes and there are common issues and there are some best practices. Just like, there's garlic for vampires, there's silver bullets for werewolves. So improving contentful paint, largest contentful paint, that's kind of a two-step process. First comes your response. So while it's speed and how quickly things get put together in your browser, it's still about speed too. So the first step is optimize your server the best as you can. Make sure it's got plenty of power to match the amount of traffic that you get in. Optimize things like database queries and make sure things work fast as they can there. And employ, particularly dynamic things, employ page caching. So basically you're not building this dynamic thing every time. Cache a static version of that and serve that. Obviously some sites maybe need to be more dynamic and can't quite do that, but definitely worth looking at. The other part of it is optimize cache headers and caching on the browser side, because what's even faster than not having to go and fetch a page or a resource from your website is it already in the user cache. So make sure you optimize your cache headers and optimize, and cache things for as long as you reasonably can. Really fine tune it. CDNs can help you move your resources and your pages on the edge to closer to the actual user. So if your server's in Europe, but you have a lot of traffic in America, then serving them from American data centers means that there's less distance for things to travel. It can be even quicker, so less lag. And the final thing that you can kind of do on this as a catch-all for most things is if you're getting things from third parties, particularly if you're using a CDN for your images. And by third parties, that means that something that's from a different host name as your main page. So if I was at tamethebots.com, but I was serving something from cdn.tamethebots.com, that would be classed as a third party. Use pre-connect, have a look it up. It's a little meta header you can put in, and that helps the browser to connect to that server ready to fetch those resources. It just removes delay. So speeding up the server and your responses and getting stuff across to your user is one part of the LCP improvement picture. The next part is making sure that the browser can then stitch all that together. It's like you've got a big jigsaw, you've fired all the bits into it, now the browser's got to put all those back together. So help it to do that as quickly and in an order that makes sense. And in an order that makes sense, it means that you might not care about all of the jigsaw being completed, just the bits someone's looking at, and the browser can go and finish off the bottom right corner with the weird little donkey while it's not looking, while you're not looking. So some good things to do here is inline as much as CSS as you can. So basically have a look at the stuff that builds the layout above the fold, as in the first few screenshot lengths that you get. So include that inline in the head. Minify all your CSS, which basically means take all the spaces, all the comments out, boil it down as much as possible, try and remove any duplication and redundant rules, and then defer what you can. So basically, if you don't need CSS until a bit later, there's methods you can find out there to defer it. Likewise, with JavaScript, try and remove any render blocking JavaScript. Render blocking JavaScript is stuff that's in the head. Basically, it will run, it will download, it will parse, and it will try and run before your site gets painted. And that includes the largest element. So strip as much as you can. You can use a method called tree shaking, which basically take out all the bits of script that you don't need to render that page. And all the rest, once again, you can defer. You can defer that by putting async or defer scripts in, or you can even just put it in the body at the bottom and have it run afterwards. Obviously, some things need to run to make your page interactive and work. So you need some testing, you need to make friends with your developers and work out that. And also beware third-party scripts doing this. Often we think of our own, we forget all the other stuff that we load in. A lot of that can be render blocking, particularly things like tracking. Do you really need 10, 20 different tracking scripts, or will one do? Do you need just one Hotjar style, page experience thing, or do you really need 10? So whittle them down as much as possible. And once again, defer those, load them in the body where you can. And with media, make sure the images that you are squeezing across are as little as possible. They're well encoded, they're small. Obviously, they've still got to look good. They've still got to be sharp, but don't put in a 10 meg straight from the digital camera picture of the boss on the About Us page. Optimize that as much as you can. Maybe have a look at things. Squoosh.app online are quite simple. You can just drag and drop into there and optimize media as much as you can, and just make it all as small as you can. That way, you're making stuff quick, you're putting it together in a rational thing, your largest contentful paint will come down, hopefully. So your next one is, let's have a look at getting better on FID. If you've got a long time of that, well, the main cause of FID being poor is you've just stuffed your threads, your main browser full of a load of JavaScript you maybe don't need. So like the LCP, it's the same advice there. Ship just the JavaScript you actually generally do need and defer what you can. Make everything async as opposed to synchronous, so it runs when there's time, not block everything and wait for me. The other thing you can have a look at is if you have long-running tasks, that basically a function, a JavaScript function that's going to take a long time, you can have a look in DevTools, use the performance tab to have a look at these. See if you can break them down into smaller steps. So rather one big massive function that fetches, parses a load of data and moves it around, can that be broken into little bits and run them as asynchronously as you can? Because basically that gives a chance for the main thread to listen to what the user's doing. It can put in, get a word in edgeways while the other lot are running. Don't overwhelm the thread as well with huge data sets. So if you had an e-commerce site and you were fetching the products in this way, do you really need to fetch all 8,000 products or just the 25 that you're showing right there and then? Because if there's a large amount of data that the browser's got to juggle and handle as a data set in JavaScript, that can really choke down the main thread. And if your site really is about large data or you're doing data intensive tasks, shift that off the main thread by using web workers. With web workers, that pushes them to the background, it chucks away there, it leaves your main thread ready to listen to commands. It feels reactive, it feels responsive, but stuff is still getting done. And there's a few libraries, there's a few things that help you work with web workers, and they work great for large amounts of data that you need to work around in the background. So on to improving cumulative layout shift. The main cause of CLS can be things like lazy loaded images and resources and ads. So I'm sure you've been there, you scroll down the page, ad appears, shoves everything down. That's not great. So the biggest thing is just make sure you reserve the space of things that are going to appear. So include sizes on images, that's almost a magical fix. So if you're putting an image in, put the height and the width of the native resolution of the file. You can still style that with CSS to be responsive, and that means that the browser will then reserve the space, nothing will jump. Ads can be a bit more tricky, but put them in the div, reserve roughly the space you know they're going to take, and when they fill that, then it's not shoving content out of the way. And don't put new content that appears later on. Ads can be particularly bad, but don't just randomly load a message above the rest of your site, or the rest of the content, unless that's in response to an interaction. Other things you can look at, some CSS animations and stuff can also cause shifts. So use transform animation properties more than height and width and things like that, and translation ones. And they can all help keep your CLS, put my teeth back in, the CLS as low as possible. So it's quite a big and in-depth product, so I really suggest having a look at the web dev site. There's both for Optimize, LCP, FID and CLS, and these cover some more of these topics and some more things to have a look at all in all. So there are a few oddities with this. The APIs are very new. This is all very new. So there's a few gotchas and strange stuff that you need to look out for. So single page applications are probably the biggest one there. When you load in something like your React fancy super web app, you're only loading one page. So the APIs concentrate on that one page. So that means that the LCP and the FID will be from the first page that the user lands on. But even though they've switched to different routes, they've loaded a different one through soft navigation, it's used the JavaScript routing, and then you're only getting the LCP, the FID for the first page. Maybe not the end of the world, it will be kind of right, but you're probably missing data for a lot of the other pages in the user journey. The big bad news is CLS, because that will keep ticking. So someone's looked at 10 pages, the CLS for the one page that they first landed on could be the CLS for all of the pages. So if you're seeing huge figures for something that don't quite add up, make sure that your page is like that. Another little gotcha, SSR, server-side rendering, is really popular for stuff. Some things like Next, Nuxt, Sapper, which is Svelte's version, kind of do something called hydration. So it starts out a single page, then it turns into, it starts out server-side render, then it turns into a client-side render page by doing something called hydration. When it hydrates, it might trip, it might cause the LCP to be measured from that point, even though your image or whatever was actually in the initial load. So that's another thing to look at when you're measuring. The other things to look at as well, particularly CLS, with interaction, you're supposed to have that half-second pause. Not everything is given a half-second pause. Like if you've got something that relies on a select element, the on-click thing. So when you first clicked it, the 0.5 seconds starts there. By the time you've selected it, that's 0.5 seconds has gone, and it doesn't take that selection into interaction. So you might, if you're showing something there, CLS might poke in from there. There's also some other things like hovers and shadow boxes and stuff like that have kind of been changing. So because they're so new, it's often worth looking at Chrome Canary and see where they're up to with it, because that's a few versions ahead. You might find differences. So you might think, I've got a problem now. I don't think it really is a problem. Have a look in Chrome Canary. Might give you clues to if that's something that's already been addressed in the APIs. So in generally, it's just something currently that's Chromium based. So it really is Chrome. It's kind of in Edge. It's hard to get out of there. What that does mean is that you're outside of Firefox world, and you're entirely blind to anything on iOS, because that's always Safari, even if it's called Chrome. So those are things to be aware of. But in general, if it's good for Chrome, it's good for all of them. They're still worth relying on. The Chromium team, like I say, they are working on a lot of these APIs. They are looking at addressing things like the SPA issue and where navigation changes and other little foibles. And in general, there's also a big push to move this to the W3C, which will standardize these further, and it will mean that it'll be across all browsers. They'll become a web standard, which I think would be a great thing for performance, because we know it's the same in all browsers. So some final thoughts, just to sum it up. Although it's going to be an SEO issue in some ways, we've probably heard of it because Google have been pushing it. It's not really an SEO issue half as much as it is a user issue, and users are more important. They should always be more important. I think it's going to be quite a weak ranking signal, but it's going to be really important for your user satisfaction. No site is ever the same, so don't be blindly thinking that every site's got to have the same performance thing. Concentrate that's good on your site. FID not so important for something where you just read in, because you just read in, but it's really important for a web app or something interactive. And most importantly, don't throw the baby out with the bathwater. User delight is always the goal. So if there's something that your users love on your site and they think it's worth the wait, it's worth the wait. So don't just blindly chase the score. Keep what's good, but just make it as quick as you can. So thank you for sticking with me. It's been a pleasure, and feel free to reach out to me on Twitter if you've got any further questions. Thank you.
Thank you very much, Dave. Towards the end of that, all I'm thinking is that this is probably one of the better talks from a technical perspective on the actual applications on Core Web Vitals that's currently being produced. In 6 months' time, someone's going to discover this on YouTube whilst looking for it because it's been announced as a ranking signal, find us dressed like this, find a Halloween deck, and not have a clue what the hell is going on. And I love that that's a future present for someone else out there.
Excellent.
No, it was a very good deck. It could. All I was doing throughout was nodding because it's a lot of key points. And it's like you said, a lot of people are discovering it and putting emphasis on it because it's an SEO issue. But
yeah,
end of the day, if we're up to, and we're not just as SEOs judged by rankings and traffic, it's also by leads, and conversions is very heavily in the experience field, and they just kind of go hand in hand with that. But no, I'd like to thank you for your time, and for I'd also love to say for actually dressing up, but I'm quietly scared at how many gifts you had to hand in. Like, this is just a normal Tuesday.
Yeah, this is just Tuesday, Dan. Yeah, we were supposed to dress up.
Lockdown hasn't been kind to you, has it? Well, no, thank you very much for your time.
You're welcome. Thank you for inviting me on.
Smart as well. And this will be, as you may have gathered from the start, this is a first in what is an edition of Halloween special crawl errors. There's a handful more coming out throughout the week of Halloween 2020. But I'd like to say thank you again to Dave for giving up his time to do the deck. And I've been silently sat in the corner as a host. So until next time, goodbye.
Bye.